Okay, welcome back everyone. Hopefully everyone had a nice lunch, so I recommend you sit comfortably. Set your alarms for about 40-45 minutes so I can at least get a smattering of applause again, but everyone enjoy. So, my name is Roebuck. I am a partner at CLA, and today I'm going to be talking about an alternative test stand architecture. So, as well as being a CLA, I'm also a CTA, and spend a lot of time in test stand. You already know two of us. You've seen Fabiola yesterday. There's myself. I'm the European arm of an international corporation of 3 people. So I'm down on the south coast in England. So today, I'm going to be using the F word, frameworks. I'm going to be talking a little bit about our framework, but I want to stress right from the start that the concept I'm going to be talking about is applicable to other alternatives, things like JKI state machine, private and public user events, but obviously in the examples I'm going to draw upon ours because that's the one that I'm familiar with. I'm also going to be talking about test stand, so caution, word of warning. I'll keep an eye out for the blow darts from the back of the room. If you see me clutch my neck halfway through, you know somebody's taken me out. So, a comment that I get a lot is, you enjoy using test stand? And you're insane? Possibly.
Sorry, which one is you?
The one on the right. So, what's in it for me? And by me, I mean Chris, I mean me. You guys have had a week off working, but you've had enough. So what's in it for me? Well, I want to reduce the number of terrible test stand solutions, and I see a lot of terrible test stand solutions. I want to reduce the number of terrible LabVIEW solutions trying to fix terrible test stand solutions that I see. The square peg into the round hole, where test stand doesn't quite do out of the box what we want, so we come up with some horribly convoluted solution in LabVIEW to make it do that. But also, I want to ensure that we increase customer success with test stand through education. Ultimately, we enjoy working on projects with a solid foundation. Working with terrible code sucks. It sucks the life out of you. So let's try and stop doing it. Now, in terms of what are you getting out of this, I think a lot of you that I've spoken to over the last few days have experimented with test stands. Some of you have some good experiences, some bad experiences. But you also find that your customers predominantly have had bad experiences. So you can help them maybe by steering them away from some of these convoluted solutions that we've talked about. So just to recap a little bit, where does all this start? Well, it usually starts with LabVIEW, with that kind of typical 3 VI, acquire, analyze, present solution we talk about. Yes, I know there's 7 VIs on there, but we're doing some kind of benchtop automation. We are capturing a signal and returning a value back to our operator interface. So that's where it starts, right? But measurements very quickly become tests. We apply some test criteria to the values that we're getting back, and it becomes a test. And we get a pass-fail out of that, so that's good. Then, we say, well, let's add some result storage. So we add some file I/O. We start writing the results out to a file. And then the customer says, well, let's add some more tests. And it gets even larger. We have more limits. And then we discover that LabVIEW is amazing. So we start using things like objects to allow hardware abstraction. We create something like the command pattern. We start using plugins to be able to programmatically add new tests at runtime. And before we know it, we've created our own sequencer. Hands up, who's worked on or has developed their own test sequencer in the past? Yeah, that's everyone, isn't it? So, not only does writing your own test sequencer require specific knowledge of the problem that you're trying to solve. But invariably, it involves acquiring specific knowledge of the solution that you came up with. They quickly become unwieldy, difficult to maintain. People leave organizations and take key knowledge with them as well. So we should guard against that. And often they have kind of funky proprietary sequencing, where you need to add a line to an Excel spreadsheet if you want to perform an additional test, or it expects there to be certain VIs and certain folders, certain names, and we have all these crazy rules. And there's no external support network. So when your sequencer isn't working correctly, you can't just go out to the forum and say, hey, I'm having this problem, who's seen it? Because chances are they don't know what you're talking about. They don't know what crazy solution you've come up with. But we see often the rolling of someone's own sequencer. So what could go wrong with that, right? So it's at this point that the customer evaluates test-out. Usually with some misconceptions as well. Some of these might be familiar to you. I've certainly come across a lot of these statements in the past. So I get the misconceptions are, it's an off-the-shelf sequencer. Why do I need that? Well, it's actually a test framework. It does more than that. It's rigid and inflexible. Actually, I'd say the exact opposite. If anything, it's too flexible. It's overkill for what I want to do. It does user management. I don't need to do user management. It does result storage. It tracks multiple DUTs being tested. But those are the things that we end up doing anyway. We end up doing user management. Oh, can we just have a different set of tests if it's an operator versus a technician? And can we allow the technician to change the test limits, but we don't want the operator to do that? We end up doing that kind of stuff anyway. We end up wanting to log results, maybe repeat tests if the results are undesirable. And I think it's at this point where things go wrong, i.e. very early in that process. And I feel like there's a little bit of a training gap perhaps, and I apologise if there's anybody from Custody in the room, because I didn't prime you on this, and I probably should have done. But this was a slide I kind of just added on the fly after a lot of conversations, but I feel like there's a training gap. Because we take test down 1 and it tells us how to write a sequence, what a sequence is. We take test down 2, it tells us how to build this nice user interface that is huge on the block diagram because of all the property nodes, but it tells us how to do that. There was a thing called the Advanced Architecture series that gave us some tips on how to do better test stand development, but that was written 11, 12 years ago. So it needs a refresh. So experience is what most test stand architects rely upon. And I did write it in, I put wanted to write, I actually did write it, trial and error. Also, where's our community as test stand architects? We don't have a test stand architect summit. I'm not aware of any other presentations that have really discussed test stand in any great depth in this kind of forum. So I think it's important that we start building those design patterns, building those trusted frameworks and best practice architectures in testing. So I'm kind of making a call out to the NI people in the room saying, look, I think there's a missing educational piece here that we can really take advantage of. So going back one slide just quickly, just to say, it is an off-the-shelf sequencer. It's rigid and inflexible is not true. If anything, it's too flexible. And please, if anybody's doing this, test stand is not a programming language. Repeat, it is not a programming language. So, where does all of this gap in the education, the fact that we've got this flexible test sequencer that can pretty much do everything, where does that all end? Well, a lot of times I see one of two things happening. So let me just play with on this. So what I see is something that I call the VI, where somebody's got some code. In this case, I've got a fairly simple API that's controlling a temperature chamber. It's going to perform a temperature adjustment and then perform a test on a DUT and return the result. So I run it from LabVIEW, it performs a temperature adjustment, it tells me what it's doing, and it returns a Boolean value back to the operator interface. So it's up to temperature, performs a self-test. Hey, it passed, it told me what it's doing. I often see that people then take their measurement that they've written like that and drop it straight into testing. Now that's an oversimplified example. It had, what, 15 VIs on the block diagram? I've seen hierarchies of over 300 VIs dropped into a single step that just return a Boolean. And that's been the only step call from test stand. So I'm kind of giving an example here. I'm dropping that step into test stand. Oh, this is test stand for everybody who's not seen it. And I've dropped that step, and I'm basically binding the Boolean output of that VI with the step result for that particular step in test stand. And I'm going to go ahead and run it. And, well, I'm not seeing an awful lot. If I hover down on the taskbar at the LabVIEW icon, I can see which VIs are in memory. But in terms of interaction, I didn't really get an awful lot while that was happening. I got this really nice XML report out at the end. So that was neat. I didn't have to do anything for that. So that's one outcome. They just take their entire LabVIEW hierarchy, drop it into test stand, and you end up with the VI. So issues, no user interaction, no indication of progress, and the outcome of any supporting steps isn't captured. So if my temperature adjustment had failed and hadn't reached its target, I wouldn't be aware of that. I'd see the test happened, it returned a pass, but I didn't capture any of the steps that got me there. Debugging is far from granular. I've got one step in test stand to debug, so I'm going straight into LabVIEW to start doing the debugging of that step. Get a few benefits. It's a quick win. You get results handling for free. I didn't actually have to write any code. I got some nice results out of that. So yeah, I got an easy win. I see an awful lot of that as well, where the test stand sequence just has a handful of steps and then these huge hierarchies behind it. The second, and I'm going to hop around a little bit in this video to a few key points. The second outcome is that we play around with test stand a little bit more. We suddenly decide test stand's amazing. Let's do everything in test stand. In fact, let's treat it like a programming language. So we end up with some libraries that we're calling. Here I've got a power supply library on the left, and I've got a data acquisition, a data acquisition unit, a library, and I'm making calls into those libraries direct from test stand. So I've started to put some hierarchy in my test stand sequence. I've got a power DUT subsequence, a power off DUT, a perform again test sequence. So I've got some hierarchy within my test stand sequence, and I'm directly calling the APIs of those two libraries. Because those modules in those libraries expect references, they're instruments, they expect a visa reference, or maybe it's been wrapped into a class, but they expect some kind of references. So now I'm doing management of those references at the test stand level and kind of cascading them in and out of my VIs. So I've created some properties in test stand. I've got PSU, what have I got? I've got PSU 5 volt, PSU 24 volt. Doesn't sound like I might get that wrong at any point and inadvertently cross-wire them. So there's potential for introduction of error now, because now I've got reference management happening in LabVIEW, but I'm also handling it through test stand variables and parameters. And we don't have the community that's been telling us in LabVIEW, be careful of overuse of globals, etc. We don't have that community in test stand, so we've got to just learn from experience what works and what doesn't work. So I've kind of now got this overly granular approach where I'm doing everything in test stand. I gave an example at NI Week, I think it was last year, where I showed a test stand sequence that have somewhere in a single test stand sequence that have somewhere in the region of 750 discrete steps. I mean, where do you start with that? There was no hierarchy. They just did everything in test stand. All of the decision making, all of the conditional logic had all been performed at the test stand level, and it had really been used as a programming language. So issues with that, reference, handle management that we're now able to perform at a test stand level. I'm now debugging across domain as well. If I've got maybe a power supply that's not behaving as I expected, I need to check that I'm handling my references correctly in test stand. I need to make sure that I'm passing the skippy string to the visa write function in my LabVIEW code. So I'm crossing domains whilst debugging, often kind of stepping from test stand into LabVIEW, back into test stand, back into LabVIEW. It's confusing, and it's not a nice development experience. It's certainly not a nice debugging experience. I can't interactively run steps across step groups, so often we take preconditions, for example, for granted. So I had my test sequence that I was showing earlier, and it had a particular test, a gain test, for example. But it required that the DUT be powered on. So if I want to run that interactively, I've now got two test sequences that I need to execute in order to kind of do that debugging of just that step. So I've either got to change my test sequence to allow me to just perform the one test, because I don't have the ability to interactively run steps across step groups. Benefits, if you've got 700 steps in a test sequence, you're going to see everything that happens. So interactivity is great. Information overload, probably. And when you've got those sequences, it becomes very easy to reuse those sequences on other projects. So you've got the reusability benefit if you've got that kind of granular approach. So we've got these two kind of opposing positions. It's a disconnect, right? No, neither's particularly desirable. So questions that I kind of ask when I see software like this: how do I test just part of the sequence? Which environment's best for debugging? I know which I prefer. I'm used to the LabVIEW toolchain. I know what tools work for me when I see particular. Fabio probably disagrees with me, but I know what tools work for me when I see a particular issue. How do I test without hardware? I'm going to start doing some kind of hardware abstraction. Where does that sit within my hierarchy? How to deploy? Hands up. Who's had success with test and deployment? Okay. Then you, my friends, have led a charmed life. I get you to choose my lottery.
You have to ask how many people are using test.
Well, that's right. How many people are using test stand? Oh, I see.
Okay. Now the previous question.
But there's questions that arise. How do I patch and upgrade installations? How do I upgrade just part of it? These are all questions. But another question is, does this mean that I now need to hire a test stand architect and a LabVIEW architect? I mean, that sounds expensive, right? It's great for some people. So, is there another way? I guess that's the question. Is there a way that we can take the benefits of one environment and use them within the other environment and really take advantage of test stand without giving up what we know and love from LabVIEW? So, I'm going to rewind a little bit, back to 2011. I was working on a project I've been asked to start working on a project to test a momentum wheel for a spacecraft. Basically, a big brass spinning disc that runs at 20,000 RPM that's used to control the position of a satellite in orbit to make sure it's always pointing in the right location, make sure it doesn't fall out of space and onto your house. And I have some fairly high-level requirements that were communicated to me. First one was there were 4 devices under test. We needed to control some hardware, a data acquisition unit, a power supply, and there was a big thermal chamber as well. And I'd also just returned from the CLA summit with all these great ideas buzzing around in my head that I was keen to try out. And I've got to go and try this stuff, it's amazing, right? So, revisiting those project requirements from a higher level. So one requirement was a functional test. Another requirement was continuous monitoring. Multiple DUTs and interactive diagnostic control for the engineers, because really this was design proving as well. We wanted to know how the thing would work under certain conditions, tested it in the boundary conditions. So a functional test, well, that sounds like a sequence, right? A functional test is a series of steps that lead to a measurement, the application of some test criteria, and a result. So that's a functional test. So that feels like a sequence to me. Continuous monitoring, well, that kind of feels like an asynchronous process. That's something that I'm wanting to do probably in the background continually, and maybe just raise my hand and say something happened if something bad happened, but I just want it to happen in the background. Multiple DUTs, so I'm thinking clones here. I need to deal with multiple instances of something. And the ability to sniff data and inject new values. So this is that interactive diagnostic piece that we're talking about, the ability for engineers to go in and interact. So, I said I've just come back from the CLA summit, fresh with all these ideas, and I've been kind of toying with this idea of, or playing around with this actor-oriented concept that everybody was talking about, everybody's hot on all these things, so I've been playing around with this concept. So, at the risk of sounding like a stuck record here at the CLA summit, brief overview is that we've got some kind of module, some kind of process that is running continually. It has some private data, and it exposes a public API to act upon that data. We can make requests of it, we can request that the module does something, and ultimately the module is responsible for deciding if you should do that, but we've got this kind of model where we've got some private data, a public API, and we interact with it through messages, requests, and broadcasts. So a module has state, public API. It has no knowledge of who consumes any of its data that it may broadcast, and it has no knowledge of who's making requests of it, and that's a key point. These are requests. We're asking that a module does something. So, how do we implement that messaging? And everybody's got their own techniques. I know James has got a technique, Stephen has a technique. Everybody's got a technique for messaging these actors that are running. In our particular case, or in my particular case back then, I was using private and publicly scoped user events based on a presentation that Justin Dawes gave. So that looked something like this. I obtained the public methods of my module, the request event. I select which one I want. In this case, I'm updating a set point, and then I fire that event. So I'm obtaining the request event. I've got an argument to my message, and sending the event. It's very easy to then take that and make that into treat that more like a sub-VI call, and to have a message that returns some data as well. So I'm requesting something, and I'm going to wait on a reply. So what I'm doing here is, part of my message payload is some kind of reference on which the module can send information back to me. So here I've got a notifier. I could use a single element queue. Here I've got a notifier that is being incorporated in part of the message payload so that the module can respond to me. So we've all done something like that. And the module is returning, in this case, it's just returning any error that occurred, but we could be returning more complex data. So we've got this request and reply. Our module, well, it's the typical cube message handler. Although, didn't we decide yesterday that we weren't going to call them cube message handlers anymore? Which, when you've got a tool set on the tools network called the Delacour cube message handler, gives you a bit of a problem. So we need a new name. So this means, isn't my test, the question I'm asking, return back to the test and domain, and I'm saying, well, isn't my test just a series of API calls? And therefore, isn't my test just a series of messages being sent to a module? So now my test sequence really looks something like this. I've got some module that exists asynchronously to my test and execution, and my test and sequence is merely sending messages, maybe waiting for a response in some cases, maybe not, but it's merely sending messages to the module that's executing asynchronously to test out. Okay. So, a real life situation, and if I return back to an instrument, I've got a power supply, it has properties of name, visa reference. I've got some methods like setting the visa reference, setting the voltage, current limit, and then retrieving some information, maybe let's get the current that's currently being drawn by the device in the test. So we've got some functions that probably look like that. So our actor, our module, it's got private data and it's got a public API that acts upon that. So we've got a set current, get current, set output, for example, and we're going to interact with it using that public API, using those messages. So that means I can use my entire API in LabVIEW and actually check out what it is that I want to do. So here I'm starting a module, I'm interacting with its public API, I'm reading back some information in a loop until it's achieved a particular situation, and then I'm stopping. So that's my simple API call from LabVIEW, but it's the exact same API that I'm calling from teststand as well. So I'm not having to do anything different in the teststand domain than I'm doing from LabVIEw. Okay? So how did that work out? Well, that means I can debug my API entirely as it will be used. I can debug that API entirely in LabVIEW. But I can call it from LabVIEW and or teststand, or even both in parallel. So it results in very, what I'm kind of calling thin teststand sequences. The references and everything is handled within the modular private data. So it's a very thin teststand sequence. So I can get back to using teststand to do what I think it does best, which is sequencing operations. Testing multiple DUTs perhaps, but sequencing operations. I'm not going to try and do any kind of resource management at the teststand level. I'm just going to use it as a pure sequencer. Were there any issues? Well, yeah. The first one is I had some issues really understanding the lifetime of the user events that I was using as the message transport when using it from teststand. We had to put some thought into who would be the creator of those user events, and that was certainly a problem that I found. I needed a nice way to address clones. If I had multiple DUTs and I had a module responsible for DUT control, I needed a way to be able to address each of my clones in a kind of a logical way that made sense to teststand. Teststand has the concept of a test socket index. It's a numeric value. So it kind of made sense that my clone would have some kind of numeric identifier. And I needed a way to, and the events and the type defs are a pain to define, but surely they're scriptable. That was something that Justin asked the question back in 2011, and they were a pain to define. They're even worse to change. So that brings me to our framework. You've seen it. Fabiola touched upon this a little bit. I just want to kind of show a few bits of this. I won't go on too much before I then show how it can help with the teststand parts that we've been talking about. So I start with a LabVIEW project, and I want to go ahead and add a new module. This is going to be something that ultimately is called by teststand, but I'm going to go ahead and add a new module to a LabVIEW project. I've got a couple of types of module that I can add. I can add a singleton where I want to guarantee a single instance will be in memory, or I can add a clonable module where I might need multiple instances. My DUT, for example, in my earlier example, I know that I need 4, so I could go ahead and create a clonable module. The scripting tools have now created the module, added it to the project. It has a main. It's our, what did we decide we were calling this thing? It's our message handler, and let me just take a quick look at that. Yeah, it's a standard message handler. Yeah, for some reason when I recorded this video, I was obsessed with pressing the save button almost constantly. I think I had like OCD when I was recording the demo. So. We also include, as part of every module, an API tester. And this is kind of core to what I was trying to achieve back then. Was I needed to be able to fully debug that API outside of that teststand environment. So one of the things that we were really keen on when we built this thing was let's have the API tester to allow us to interact with the module. So I have the API tester. I'm now going to go ahead and add a second module. So I added a singleton. Let's go ahead and add a clonable module. And what I'm going to do now is show how we can use the API tester to interact with that module and really test the API and understand how my module works. So I've just added a clonable module. that's the API tester for the module, so I can start an instance of our module, show its front panel. If you've ever, okay, I'm interacting with our module, sending the do something message, do something and wait on reply, so I'm checking out my API. Okay, and then I'm going to go ahead and start a second instance of the module. So now I've got two instances of the same module running, and you can see in the list I've now got two modules, both with unique identifiers. If you've ever debugged re-entrant clones, you'll know what a pain it is. So being able to, especially from test stand, where you're trying to debug, hang on a second, that didn't work, what just happened, being able to show the block diagram of the clone instance that you just sent a message to saves an awful lot of time. So we've got our modules, and I think that's pretty much it. What do we do next? Oh, I'm going to go ahead and add an event. So I'm going to add a message to my module that I can send to it. So I'm going to create a request event. I want my module to do something. So I'm going to create a simpler message as I possibly can. I'm going to create a message that has Boolean data associated with it. I'm just going to tell my module, here's some Boolean data, and I'm calling it my Boolean. There we go. I defined it as Boolean. I said okay. The scripting tools has created the typedef, the user event, and has added cases to the block diagram for me to go and complete. So I'm simply going to go ahead and create an indicator in the message handling loop, assign the event handling loop to that particular request event, and I can, if you're interested, I can show you offline whether this is whizzing through there. So I've added a Boolean to my front panel. Let's go ahead and close the main. I probably saved it about 3 times as well. And I just need to be able to test that message now. So all I'm going to do is add a Boolean control to my front panel of my API tester and make a call to that API method of my module. It's there on the block diagram. It requires a Boolean input passing to it. So I'm going to go ahead and put my Boolean inside the case structure, inside the event structure, wire the new value, and I can now run this and interact with my module and send it Boolean data. So let's move it up to the side. I click my button and my light switches on and off. So that's me now able to send a message to my asynchronously running module. But that API call that I've made, I've tested it in my API tester, but I can now call it from a LabVIEW application, or I can call it directly from test stand, and it will have the same effect. It will affect the behavior of my asynchronously running module. So what does this mean? So it means that we can entirely debug my API from the LabVIEW environment before I start working without having to really generate any test harnesses to cope with the fact that maybe I'm doing things in a different order in test stand. I can replicate the order of the API calls from my API tester the same as I would be doing from the test stand. So here I've got a power supply module, I think, in this example. So there we go. I spent way too much time on that. So I've got a power supply module, and the methods that you typically have in a power supply are in the message handling loop. So things like setting the current, setting the voltage, getting the current, turning the output state on and off. So I've got a case for each one of those, and I can now interact with it from my API tester. So I'm now going to go ahead and run my API tester, start a clonable instance. I think I actually go ahead and start 2. So let's start a second instance. So now I've got 2 power supplies that I can interact with individually. So I can go ahead and interact with just one of them by using the clone instance, the address of that particular clone. I'm going to go ahead and set a voltage, set a current, turn its output state on. Obviously I've not affected the other clone instance. Now I'm going to go ahead and deal with the other clone instance. Or I can choose to deal with all of them at once and send a message to everybody who needs to hear about it. So I could say, for example, stop all. I need to just shut down everything as quickly as possible, for example. So I think that's actually what I'll go ahead and do then. So I select that to all and stop there. So I've now got this ability to debug my API entirely from LabVIEW, So now I'm going to actually do what I said right at the very start. I'm actually going to start calling this architecture, this method from test stand. So I've got a test stand sequence, and I've got a LabVIEW project open in parallel to that. And my test stand sequence makes calls to a couple of different modules, a temperature controller, a device under test. I think I've got a power supply in there as well. So I'm just showing that in test stand, the steps that I'm actually calling are the public API methods of each module. So I've gone ahead and executed my sequence, and I've called some of the methods on the temperature controller. I can, in parallel, open the API tester of that module. One little caveat, I need to change the application instance to main instance, but now I can run my API tester in parallel and actually affect it. So whilst test stand's running, I noticed that the ramp rate was too slow, and I needed to get a move on the arm. It's nearly 5 o'clock, it's time to go home. So I wanted to get a move on. So I'm running the test stand sequence, but I now actually want to inject a new ramp rate in there. I actually want to go ahead and change the ramp rate to 10 degrees per minute. So I've sent a message to my module whilst test stand is running saying, actually, let's change that ramp rate. So I can interact with it. And it's bi-directional. Because I'm just using the user event, I can inject new values, but I can also sniff values coming back. So maybe that module was a headless module that didn't have a nice graphical output, but I want to see what's actually happening behind the scenes. I want to see what data is coming back from it. So I can use my API tester to actually go ahead and do that. And then my test stand sequence finishes, my module closed, and we go with it. So I can use that API tester then as a sniffer or as a way of injecting new values at runtime. It makes debugging of clones from test stand so a lot easier. So let's go ahead and run the sequence. Here I've got similar thing, thermal chamber, multiple devices on test. I think I've got a couple of power supplies this time. Yeah, so I'm performing a temperature adjustment. I've got my power supplies. So maybe one of my power supplies is not behaving the way I quite thought. Maybe it's a slightly different variant, and I'm assuming the sticky commands are the same or something like that. So I can actually go ahead, launch the API tester for the power supply module. Schoolboy error, I think, or maybe on the next slide, but I forgot to change the application instance. I can hit the little refresh button, and it returns the index, or the address, if you will, of all of the clones that are running, and then I can choose to interact with one of them. That one, I don't know if I wasn't happy with that, so I can just click on Show Block Diagram and see the block diagram of that particular clone instance while test stand is interacting with it. So that gives me a really powerful debugging tool. So I think the next thing I do is I go ahead and interact with the temperature controller as well. So let's see what's going on there. So I can see the block diagram. Let's inject some new values in here. Let's change the way that thing's working. Set a temperature set point. This is where I did my schoolboy error. I forgot to change the application instance to main instance. Go ahead and run it. I've now got control of my thermal chamber, and I can do things like adjust the ramp rate, adjust the set point, turn the heater on and off, and interact with it. Test stand's still running in the background. We're going to go back to that in a second. So we get to our target temperature, and we go back to test stand's still running, it's still performing the test that it thinks it's doing. We've just interacted with the module and changed a few things. So, kind of getting towards the end now. Hardware abstraction layers. Until somebody correct me, I can't remember, Steam probably knows, but pretty much until recently we couldn't do this in test stand, where we would want to make calls to classes and dispatch different child instances. Right. So we couldn't do this in test stand. We didn't have the option. The only way to do it was to actually dispatch, do the dynamic dispatch inside of VI, and call that VI from test stand. So we didn't really have that option. We do now. But one way around that was that if we had our asynchronously running module, we do the dynamic dispatch inside. So I'm dealing with a power supply module. I can have a message type that is, you are this type of power supply. How do I say it? Keysight or whoever. But at runtime, send it, you are this type of power supply, and then do the dispatch inside our asynchronously running module. The final kind of thought before I wrap up that I want to leave you with is, wouldn't it be really nice if when we're creating that public API, if then we know we're going to use it in test time, so let's go ahead and put it in the test time palette. Let's put the public API, the modules that we're creating, in the test time palette so they're there for us to use, and maybe even simplified as well, right? Where we're not going to expose the whole complexity of the module, but just those public API methods that we want people to use. So I think that's something, that's definitely an area of interest. So, how did it finish? We fixed the event lifetime issue. We can talk about more about that offline. That's a subject for a summit in itself. We've got a way to address clones, and we handled this, the type of creation through script. You can learn more online. We've got a blog. Shout out to Justin for the inspiration behind where this really started with the privately and publicly scoped user events. But toolkit's free to play, and if anybody wants to contribute to the blog, by the way, we're looking for guest presenters. So grab me out afterwards and we can talk about it. So, any questions? Is that good? Is that bad? Is this where the blow darts come out?
We're usually setting up a test sequence, calling an API.
Yep.
So do that step by step. But what we are doing is that we encapsulate each test step, let's call it like that, to be a module and call it from test end within a certain hierarchy.
Yeah.
Because that makes it easier for our developers who are not used to test end to program that module that can be tested without test end, and we can just call it via the API.
Yeah, and one thing I have thought about was actually taking the custom step type that little bit further. Instead of just having the palette expose the API of the module, actually just have the palette expose just a step for the module that have different functions, so that they get the nice interactive UI. They can select from a drop-down list the function that they want to perform. Okay, and that step closes and saves that state in the step properties.
Have you thought about maybe building sequences to validate your modules?
So the question was, have I thought about building sequences to validate the module?
Yeah, so having yeah, so not do test the module itself, the API, if you like.
That's another thing.
Oh.
Since I presented a unit testing, somebody said, we use test time for unit testing, we said we were going to do it.
Yeah. It's on the list of things to play with. So, one of the message types that I spoke about was this thing. So the request and wait on reply. So as part of the response from the I'm sending a request to my module to do something. As part of its response part would be, did any error occur whilst I was doing it? So on the right hand side, I'm actually returning the error as part of the response payload. So if something occurred, that error is actually getting fed back out in my step. So test stand would be aware of it.
You see the difference in when you design your modules on which what they should broadcast and what should be requests, depending on if you have used a test stand or in
Yeah, I mean, it ties back to what James was saying actually yesterday. We kind of take it for granted that when a sub-VI call is inherently blocking, right? We're waiting for it to return something, and it was more about that kind of concept of when I've made the call to the module, have I got everything that I need at this point? So I initially found myself creating lots of requests, and then actually changed some of them to request and wait on reply, so that I could get information back that maybe I hadn't initially assumed. So actually, I use a lot more request and wait on replies. And one of the 3.0, I think that the improvement where we'll include a broadcast. So as part of creating any request and wait on reply, we'll automatically also create a broadcast. So not only are you returning a response to the caller, but you're also broadcasting that information out to anybody who also may be registered to hear about it. So the API tester, for example, it's a great way of saying, well, test stand did a request and wait on reply, but I want my API tester to be aware of that response. So we we effectively build the broadcast automatically. So that's an improvement that's coming on the next version. Thank you very much.